This is our SolidWorks model of the James Webb Space Telescope. Some of its main features include the spacecraft bus, which powers and controls the telescope, the 5-layer sun shield keeping it cool, and the primary mirror made of 18 hexagonal gold-plated segments. Together, these systems allow the James Webb Space Telescope to observe the universe further back in time than ever before.
This is the spacecraft bus. It contains major subsystems which are crucial to the operation of the James Webb Space Telescope. The altitude control subsystem senses the telescope's orientation and directs the propulsion subsystem to maintain a steady orbit. The communication subsystem receives commands and sends data to and from the operating control center. The command and data handling subsystem stores data and decides where to send the commands.
The sunshield of the James Webb Space Telescope is one of its most important features. The components in this assembly highlight its design as a stable and well-supported structure. Beneath the bottom layer, 2 supporting arms act as a connection between the sunshield and the space bus. Attached are 3 grids of metal to reinforce its structure, while multiple rings around the arm provide added stability. These arms connect to spreader bars located along the top, bottom, and sides of the sunshield. The spreader bars maintain the spacing and tension of each individual layer. There are 5 layers in total, with the first sun-facing layer being 0.05mm thick, and the remaining 4 layers each 0.025mm thick. The layers are made of Kapton and coated with a thin layer of aluminum. Overall, the sunshield provides thermal protection for the telescope, blocking heat and light from the sun.
The momentum flap on the James Webb Space Telescope is a large adjustable panel mounted on the back of the spacecraft behind the sunshield. Its purpose is to balance the force of sunlight pushing on the telescope. Because the sunshield is so large, solar radiation creates a constant torque that would slowly rotate the telescope. Instead of relying heavily on thrusters, Webb uses the momentum flap to counteract this force. By changing its angle, the flap shifts how sunlight pushes on the spacecraft, effectively acting like a trim surface to keep it balanced. This reduces the need for fuel-consuming corrections, helping extend the telescope's operational lifespan.
The Integrated Science Instrument Module provides support to the primary and secondary mirror while also attaching it to the spacecraft bus and the sunshield. And with the use of the added door, we're able to see inside of the module.
This SolidWorks assembly showcases the core structure of the Space Telescope. Starting with the main optical components, the primary mirror array, the center baffle, and the secondary mirror. Supporting the optics is the forward tripod assembly. These tripod struts were designed to be entirely hollow and lightweight, featuring strategic weight reduction cutouts to optimize the overall structure. Finally, integrated next are the top-mounted communication antennas along with their structural mounting plates.